So I'm here to talk to you guys about Bundler. You may have used it before. My name is Terrence. I'm the dude. I'm the guy who wears the blue hat everywhere if you've met me before. I go by Hone02 on Twitter or H1E on GitHub. And unlike the program, my name only has one R. So if you email me at Heroku, make sure to spell my name right, because I won't get it otherwise. I live in Austin, Texas, also known as the taco capital of the world. So if you're ever in town, feel free to ping me, and I will take you out for tacos. And I do some community stuff. I work on Bundler, Rescue, do some stuff with Rails Girls. Definitely, if you haven't taken part in something like Rails Bridge or Rails Girls, I highly encourage it. Based off all the stuff from the keynote this morning, it's a really great experience. I'm a senior Ruby engineer at Heroku, and I'd like to thank them for sending me to South Africa in the first place. They paid for all my travel and stuff, so I can come speak, as well as letting me work on tooling and other things during work. And actually, one of the greatest things about Heroku is we have this vibe team. And what's really cool about them is they sort of curate the company culture and really allow us to focus on making things really awesome. So allowing us to work on tools in the Ruby community and sort of removing all the other stuff that we have to do. And actually, one of our vibe team members, Kathy, is here, sitting over there. And so if you ever want to talk to someone about culture and other things, she has a lot to say. So definitely hit her up before you leave. And she's actually going to help me in this next part. So I don't know if you guys know, today is Friday. And one of the things I really love about the Ruby community is the community itself, like Constantine was talking about yesterday. And there was this thing that Aaron Patterson started a while back where every Friday he would tweet pictures of him, I guess, hugging a camera, and then he'd tweet it out, and people would send Friday hug pictures back at him. And then there was this whole site, hugfriday.com, that was created that sort of collects all these pictures. And as I've gone around the world talking at conferences, I've liked to do Hug Friday photos everywhere. So if you all could stand up and do a Friday hug photo, that'd be awesome. I don't know. You gonna get on a chair? Are we good? Awesome. Thanks, guys. So I guess enough intro stuff. So on the agenda today, the first thing to go over Bundler and sort of why we started using the API there, and then next part, we're going to go into Ruby Gems and when it went down in November, or October, I guess, and then talk about the Bundler API, sort of the architecture and how it works now, the new one that we extracted out. And then depending on how much time we have, there's potentially a bonus round of stuff for this project that I've been working with for Bundler API. So let's get started. So Bundler, if for those of you who are not familiar, it's the dependency manager in Ruby. So you list your gems, and then it goes and figures out the whole dependency tree that you need to get your app working. So the common interface that you use is just bundle install, and you type that, and it goes and downloads all the gems that you have. And then for our example that we're going to use through the whole presentation, we're just going to have this really simple gem file. Sinatra, because I love Constantine, so we're going to use that. So just looking at, to sort of understand why we went and used the API, let's look at what it looked like before we started using it. So back in the bundler 1.0 days, when you ran bundle install, a lot of you older people who've been using Ruby definitely recognize this fetching source index message. And then you would like wait, and like about after 18 seconds, it would eventually install the gems you needed. And I think this was a total of like 5 gems. It's like Sinatra and like it's 4 dependencies or something. 3. Well, I think there's like rake somewhere in there. Yeah. So, you know, you're sort of wondering like why this is so slow. And so I guess like the theme of the conference so far is like, we're going to now talk about mark and sweep. So like some cowboy story here. But in actuality, so to sort of understand why it's so slow, we have to look at how bundler actually does the dependency resolution. And it has this index file that sort of contains all the information of the dependencies that it uses to do the resolution. And inside of the index, we have this fetch all remote specs method. And this is how it pulls in all the information. And inside this method, we use Rubygems. Rubygems is spec fetcher to fetch like a bunch of files. And we pass like 2 different configurations, and it gets us the specs.48gz file and the pre-release specs. And the specs.48gz, if you're not familiar, is called the modern index. And it contains all of the gems that ever existed that aren't pre-releases. So it's every gem and every version, every gem for every platform that is ever available. And so if we go and download it, so this I did when I was preparing these slides like 2 days ago. It's about 1.2 megabytes. And so I've used similar slides when I was in Heroku in Singapore. And when I did those, it was about 768K. So within like 8 months or so, it's almost doubled in size. So as you can see, it's like growing pretty quickly. But so a lot of people have this misconception that, oh, it took a really long time back in the day because it took forever to download these gems, or the index. But clearly if you're on like a pretty decent connection, and the fact that all this stuff is hosted on CloudFront, it doesn't actually take that long to download this file. And so if we look at what's actually inside of it, you get an array of all the gems, and you get this tuple of the gem name, the gem version, and the platform that you're using, or that the gem is using. So we have Ruby, or if like you're using Windows, there's like some Win or SigWin, like x86 stuff, or Java, stuff like that. But the one thing you notice here is that there's no dependency information here. So we don't have like a complete gem specification. So bundler has this fake remote specification class that we create that we're using to simulate the specification file. And we also need to have a spec fetcher to be able to get extra information like the dependencies. So using the remote fetcher from Rubygems, we can download this gemspec.rz file, which contains even more information. So in here, you see it contains the dependencies for that gem. So coming back to the original method, we create a bunch of remote specifications for every single gem inside those indexes, and we put them in this big index inside of bundler. And then given all that, the resolver can now go and try to resolve your dependencies. Now, as you can imagine, like that takes a really long time because you're essentially creating a ton of objects, right? I think there's, what, 400-some thousand total gem versions out there right now on Rubygems. And so you have to create a new object for every single one of those. And then you need the whole dependency graph because you don't know what any of the dependencies are. So like if you look at Sinatra, like you go and you have to fetch the version that you're getting, and then you get its dependencies, and you have to go and fetch the gem spec for those. And so when bundler originally came out, you couldn't even run bundle install for a simple like Rails app on like a Linode 256 box because you would just run out of memory. So this is clearly a problem, and then over time, you're definitely running into like it's just going to get bigger and it's going to be a worse problem. So we realized we had to do something here. So when, if we take this just the latest stable version, but it came out in bundler 1.1, we started working with the API that the Rubygems guys made. And you can see that the install message is a little different here. And we have some dots and stuff. And then, so instead of 18 seconds, it now takes like 3 seconds, like pretty significant speed improvement. We're pretty happy with that. And the secret to all this is this API endpoint that they built for us. And it essentially allows you to pass a comma-separated list of gems that you want to get first-level dependency information for. And in there, we can see like sort of the response there. So if we pass in Sinatra, we get the name, the version, the platform back, and then also now the dependencies. So now we don't have to fetch that gem spec RZ file for the gems that we're interested in. And then you get all the versions of that particular gem back. So in here, so instead of fetching those monitor index things, we can now just have this recursive method that goes through and like you just intuitively think in your head, like you start with the top level gem file, you pass in Sinatra, and then you keep going through until you run out of dependencies that you need to fetch. So if we look at a example here, like given Sinatra, it has tilt rack protection, rack, mongrel, in some version of Sinatra, I guess, back in the day. And then it gets its dependencies, and then eventually you get an empty list, and you're done. And then if we go back, so now we can create these endpoint specifications, and then at the end we can pass the dependency information in, so we don't have to fetch it. And so this allows us to create a significantly smaller graph because we don't need all the other gems, right? We only need the gems that we're interested in, or the gems that have like dependencies that are related. And so given that, we can just have, it's much faster, like we don't have to create nearly as many objects here. So let's look at, so everything's all good. So let's look at like rubygems.org and when it went down and caused a lot of sadness. So back when I was working on this, when it was going down, the current infrastructure looked something like this. They had a single box that was a 4-core machine, and it ran everything. It ran the app server, it ran Postgres, it ran Redis. And I think they might have had another box that did all the Nginx routing stuff, but maybe that was actually on the same box. I don't quite remember. But as you can imagine, that's like a lot of stuff for a single machine to be doing. Like a lot of times when you build an architecture like this, you would split out the database or Redis into its own machine. So on October 17th, on Wednesday, RubyGems went down. And there was some serious downtime, and in order to bring it back up, they disabled the endpoints. And so we sort of looked at like, why did it go down during that time? And I guess Bundler 1.1 was a little too successful, so ended up taking up 70 to 80% of the traffic to that machine, like in total, which is a significant amount. And we were using Marshall to sort of send the data back and forth between Bundler. And the reason we do this is because Bundler can't have any dependencies, so we have to rely on standard lib. And so a lot of people are like, well, why don't you use JSON? But like Bundler has to support both 1.8 and 1.9, even though 1.8 isn't part of the reference implementation anymore. There's still a lot of people like the GitHub guys who are using 1.8 in production. We still have to support that. So JSON is not part of standard lib in 1.8, but it is in 1.9. And if you looked at the resource usage, Ruby took up 380% of the CPU, like for the 4 cores on that box. So there really wasn't a lot of CPU for any of the other tasks on that machine. So the solution for them was turning off the API and bring rubygems.org back up. So this meant you could still bundle install and do things, but you were relegated, you were going back to the Bundler 1.0 days where you had to fetch everything from the index because the API wasn't available anymore. And me and Andre and the rest of the Bundler team were pretty unhappy with this. Like we worked hard to make Bundler like so people stopped hating it, and now they just like turned this whole thing off. And so we worked on a proposal to extract that API into a separate service, and we met with them on the Friday of that following week, built a prototype and sort of showed it to them, and that was sort of greenlit as the path forward. And the API for that is now hosted on Heroku. And this is sort of the application architecture that we have for that. We have this API endpoint that is the Sinatra app that replaces that API dependencies thing. And then we also needed a way to handle syncing the code. So since it's now a separate app, we didn't have access to the RubyGems database anymore. So we now had to maintain our own cache of the metadata information to provide to users. And then we also talked about doing webhooks, but this wasn't really on the table initially because in order to do a major change like this, we had to make the amount of change required in the infrastructure itself, since they're running into problems, as minimal as possible. So by just relying on polling initially, we could essentially do all the brunt work up front on our end and not have RubyGems really change anything besides change the routing inside of Nginx to point to our application. So if we look at the API endpoint, it's comprised of part of the Postgres database from rubygems.org. So they gave us a dump of the RubyGems table, the dependencies table, and the versions table. And as you can imagine, just thinking about this information, the RubyGems table contains most of the metadata information, like description, download, or description, author name, the name of the gem itself, and then versions would take a RubyGems foreign key, and then the actual version number, and then dependencies would link different RubyGems to specific versions and their dependency. And so given that, you would construct a really awesome SQL query that took us half a day to get right. And so the thing, given our Sinatra example, right, you need to, if you pass Sinatra in, you need to be able to fetch all of its versions, every version of Sinatra for every platform, and then get its dependencies for that. And then we want to restrict it to only the runtime dependencies, because when you're booting up an app, you don't really need the development dependencies because you're not developing the gem. And then there's also this index attribute here, because gems can be removed from the index. So gems that are yanked, we don't actually want to return those as well. So running this query, we eventually get all the information. And so given this endpoint here, so this is literally the code we have in there minus the instrumentation stuff. You just do a Marshall dump on the dependency information, and we just have a method here that does this SQL call and just sort of massages it into the format that we need to return back to Bundler. So that's the endpoint. And so let's talk a little about the syncing code. So the syncing code was pretty important because it's what allows us to keep everything up to date. And we were trying to figure out how to do this in a sane manner. And so we settled on that this thing had to do two things. We needed to be able to find new gems and put them in the local cache of the metadata that we needed, and then find gems that were removed from the index and remove them from our cache, or not delete them, but mark them so we don't return that information back. And so we used a threaded consumer poll, which I'll go into more detail in a second. And then literally just iterated over every gem spec that we got back from the modern and pre-release indexes, and looked at whether we need to yank it, and looked if it was new and whether we need to add it. So we did this for every single gem that was possible on a regular, I think it was every 5 minutes we ran through this. And so that meant there would be up to a 5-minute delay between when you push a gem and when it would be available to API. It wasn't ideal, but it was something we were willing to live with than not having any API at all at the time. So if we look at the consumer poll, I don't know how many of you work on worker queues, but this is just a very simple one. It's a threaded consumer poll that contains its whole queue in memory. So when you restart the process, all the jobs on it disappear. But we didn't really need anything too complicated for this. So you specify the size, which is sort of the number of threads you want to use to do this work, and then you just use the queue class from the standard library, and then you set up methods like I need the ability to push jobs onto this thing. When it starts, I want to start up all the worker threads, and then I want a way to wait for all the worker threads to finish working. And then there's this concept of a poison object. And so this is what you do to sort of signify that you're done with the consumer poll and that it's ready to shut down. So if we look at the run loop that gets started every time, we have a special check for this poison object. So if we pop a poison object off, we know that we've hit the end of the queue, and then that we're done. So if we look at the code here, after we enqueue all the jobs, we insert all the poison objects, and then wait for all this stuff to finish. And then when that's done, we're done. So that's, and then we also have the interface for the job is pretty simple. You just instantiate an object, and that instance of it just needs to conform to this run method. And so that's how that was the interface for our worker. So pretty simple. And then, so we tried different things to speed this up, because the initial run of this took, I think, like 16 minutes, I think, every time just to go through the index. And obviously, it's going to take longer as we get more gems and stuff. So there was things we did, like we had a 304 check. So if the index was not updated and it has not been modified, then we just skip that iteration, then we'd wait another like minute and run again. And then we would also try caching all the information of the local gems inside of a hash in memory, and then sort of keep that in memory so we didn't have to hit the database for every single call to check if that gem existed during the add job. So that's sort of the summary of the polling stuff. And then recently we actually enabled webhooks, and so we really wanted to solve the problem of you push a gem and now you have to wait like 5-10 minutes for this gem to be part of the API and be able to bundle again. So we enabled, so RubyGems has this concept of webhooks. I don't know if many of you guys have used it before, but webhooks allow you to get notified when a gem has been pushed. So you can have it hit some endpoints and have that endpoint do something. Like maybe when you push a gem, it notifies Qbot to like put an anime GIF inside a campfire or something. But so we were going to use webhooks to notify us of every time any gem was pushed so we could update our cache. And we actually got a special code path inserted into RubyGems, so this is called every time as part of the code and not part of the normal webhooks route. So as you can imagine, this webhook's pretty simple. You just need to provide all the metadata information and send it to us, and then we update our local cache with it. And then we just need to have this RubyGems token thing to ensure that not everyone can just like start inserting stuff into our database. So just a minor security thing. So this is just the token there. And then the endpoint is pretty simple too, right? You have an endpoint that adds the specifications. It reads JSON, and it literally just calls the same job as the polling code and adds it. So pretty simple and straightforward. So project's not all too complicated. So if anyone's interested in looking at the code, it's completely open source. It's under the RubyGems GitHub repo under Bundler API. And if any of you are interested in actually working on it or helping me improve it, I'd be more than happy to talk to you during the break or after while I'm here, or reach me out online. And that's kind of all I had for this part of the presentation. So I don't know if you guys have any questions before. What's up, Constantine? Mark and Sweep? It's more or less the production code, I think. Inside this? I think we have the escaping code that made this too long. Yeah. Sorry, bro. Yes?
So do your timeouts work?
I don't actually know how this timeout is implemented. But the timeout is mostly there, so like if a gem push happens and like maybe the API, like maybe our bundler API is down, you can still get the gem push to go through after 5 seconds. So it doesn't actually prevent you from pushing gems. Yes, Jacob.
Is there a reason that as a maintainer of REST, you felt the need to implement your own feature?
I didn't want to. I mean, it was just like a very simple thing. I didn't need to have a, I guess a data store just to do the worker stuff. So we just wanted to keep it in memory and keep it simple. I mean, I also pulled a lot of code that I've been working on for REST-U into this thing. How much time do I have left? How much longer? There's like, what, like 15 slides or so left, I guess. All right, sweet, bonus round. I didn't really practice this section, so I don't know if I have time for it. So we'll see how it goes. So there's this project that I've been working on that's been really interesting to me. It's called the Bundler API Replay Project. And the whole premise behind it is that I wanted a way to test changes to Bundler API and without actually taking the service down because a lot of people depend on it, and it would probably be bad if I put something in production that broke things. And so that's the whole idea behind this project. And so this is open source too. If you go to under my GitHub repo, Bundler API Replay, or yeah, you can find it. And it's definitely a work in progress that I'm still trying to work the kinks out for. But I've been working on it over the last month and a lot this last week trying to get stuff ready for this presentation, but didn't quite get far enough. So we have a labs feature at Heroku called HTTP log drains. And one of the benefits of having all this stuff at Heroku is that so when you're using Heroku, we combine all the logs into a single place that you can access using Heroku logs. And so if you use Heroku at all, you've probably seen something similar to this. And this is just sample log output from the router. And then you also get your web output and other things. And so there's this concept of log drains, and this isn't anything new. You can have UDP syslog drains, and so you can send all of your Heroku app traffic to some syslog on some server of yours. But recently we had a feature which is in labs called HTTP log drains, and so this allows you to send all of this data to an HTTP endpoint as the payload. And so thinking about this, I figured we could actually get all this information and then sort of keep track of the traffic that's coming to production and then replay it somewhere else. So looking at the Sinatra app that I built for it, we have the logs going to here, and we just need to read the payload of this data here, and then check if this is actually a router log, because we just want to get the path information out. And then we're going to keep track of a bunch of sites that we want to replay this traffic to, and then, again, enqueue this onto a job that gets handled elsewhere. And so now we can get all the traffic and replay it somewhere else. So this was really great because it allowed me to set up a bunch of staging instances of the same project. So I could test things out like, what does this look like if I was using JRuby? JRuby seems to be pretty hot these days. What about like different web servers? Like we could use Puma, we could use Thin, Unicorn, things like that. How about if I want to try Ruby 2.0 instead of Ruby 193? And so it really allows you to test things out and see what the performance characteristics are using like pretty close to production-like traffic. So that meant we also had to do a bunch of instrumentation along with it. So we're using the Librado service and also the metrics gem to do all the reporting there. And if you've never heard of Librado, it's a pretty great service for doing graphing. I think the GitHub guys use it. We use it a lot at Heroku. And it's a great service for just like getting information into pretty graphs and stuff. And then Joe, the founder and CTO of Librado, has a great talk on instrumenting and putting metrics inside your application. So setting up was pretty simple. You just need to get a Librado account, get these user and tokens, and then when you have this metrics gem, you just need to get the Librado reporter, which knows how to talk to the Librado service, and then put this in your app somewhere. And then after that, for development mode, I don't want it spewing logs all the time about every time it's reporting. So I just send all this stuff to DevNull because I don't really care locally. And then to use it, you just do something like this. So inside of our app in production, we just wrap timer stuff around different calls, and then you can name what the name is in Librado. So you can get timer information, you do histograms, you can do counts and things. Definitely pretty useful. And so as an experiment, so in production we have, we're running Ruby 193. It's on 6 dynos, which if you're not familiar with Heroku is basically like 6 processes. And they're all running thin. We used to run Puma, but I ran to like a crazy bug with it that I don't know how to debug that would just cause the thing to hang but still accept connections. So we did that for like the first 2 weeks and I couldn't like track it down. So we just switched to thin because it worked. And so I wanted to compare it because a lot of people have been doing some JRuby stuff recently. I mean, there's been a few talks at this conference. And one of my problems with a lot of the benchmarks and stuff is like they're all like contrived situations. Like I have a loop and I do this stuff. And it's like, obviously the JVM is better at this because it's been optimized for like the last 10 years to do things like that. So I wanted to see what JRuby and how it would perform in a real production setting. And so this was, I just pulled this this morning. And so it's a little messy, but the blue line denotes the 95th percentile. So it's the really like jaggedy thing that goes up of our JRuby server. And then the purple line is the production 95th percentile response time. And then the orange line is the 1 minute rates of requests for our MRI app in production. And then the green line is the rates for the JRuby app. So as you can see, I guess like it's like on average, the JRuby app is faster, but the tail end, it has some pretty terrible, I guess, spikes for response time, which I thought was interesting. Like I've definitely seen it, like I've been watching it for the last few days, and it definitely fluctuates pretty heavily. Like sometimes it's definitely pretty smooth, and then sometimes you get graphs like this. And then the requests per minute almost never go above production, but I think that's because it's limited by the fact that I can never get more traffic than what is going to production on that app. So you are limited in that sense. And then there is definitely a little bit of a delay between sending out the log drain, it parsing it, and then replaying that traffic back to your app. So given that, there's definitely certain limitations behind this project. The lag that I was talking about, and then also like the only reason this works is because Bundler API is a stateless application. So I depend on no session state. And so if the Ruby gem side never changed, every time you send the input in, you should get the same output. So it's deterministic, unlike other things in Ruby. So yeah, that's sort of the state of where this project is in. Definitely for more experimentation, I would like to sort of stage up our production app in a similar setting. And so I'm not measuring directly against production. So it's definitely on more even footing. There are things I did, like make sure we were using the same database and have them separate. So there are two mirrors of our production data running on that stuff to try to sort of eliminate as many variables as possible. And then special thanks to, I guess, like Andre, who's one of the other core members on the Bundler team for helping out a bunch with this project. And Larry has been super helpful with instrumentation here. So he did the initial Librado instrumentation on the Bundler API project and been super helpful there. And then Daniel Farina is the guy that helped me with the SQL query and helped me get that prototype up and running. So yeah, it's definitely all I had. I don't know if there are any more questions with this stuff, but yes? When it got pwned? Yes. That's definitely still under heavy discussion. I mean, I'm definitely interested both from Heroku's perspective and as a member of the community. I definitely like to see gems signed. I think it's kind of tricky. Like, what does the workflow for that look like? I mean, so if you look at a lot of Linux distros, like if you didn't have signed packages, like they would become a joke of, like that distro would become a joke, right? Like you definitely need to have signed packages there, and we definitely don't want to go through that again, because I mean, it's bound to happen again, and I think it would be stupid for us to assume that it's not. But yeah, I think we're still trying to work through workflow stuff and how that would work both on the server side and then after you sign it, all the clients have to verify it. Like, it doesn't help to sign it and not actually verify that the gems are what you say they are. And I know within Bundler, there's a lot of interest there as well. I think we can get like an 60-80% solution with potentially just doing checksums of the gems you install locally. And so when you deploy to production, Like if you verify that the checksums are the same, they might not be the gems on Ruby gems, but they're at least the gems that you installed locally. And I think that would give you a lot of confidence, and it doesn't solve that particular problem, but it definitely helps with a lot of other things. What's up, Jacob?
Were you comparing, did I get that right, 5 bins versus 1 Trinidad?
Yes, I was.
They are concurrency?
Yes.
Okay. So JRuby was slower kind of, but it was running a lot of processes.
Yeah, for sure.
Really fast.
Yeah, I was definitely super impressed, even with the tail end stuff. I didn't see, when I bumped up the number of processes of Trinidad that were running, I didn't see huge performance improvements though. So it was kind of interesting. But I definitely would like to test this out over a longer period of time than the week up to my talk. So.
Did you look at using rack proxy at all when you were doing the log script?
I've not. Would you be interested in helping out with that?
Maybe. I mean, it sounds like the logs report pretty well, so I was
Yeah.
curious if you had to look at trade-offs.
Yeah, no, I haven't looked at rack proxy, but I think Donish says I shouldn't do things alone. So if you want to come help me, I'd be more than happy. Cool. I think that's it. Thanks, guys.